Okay, it's recording. Right. That's the diagram shows these two curves. It's on. Y equals e to the 2x and 8 e to the minus x. The shaded region is bounded by the curves and the y-axis.
How do they know?
Well, they do know. This is the thing.
Oh, is that one?
It's actually, it made it difficult to mark because I do kind of feel if you need to write in a question on a paper that calculators are allowed, do it without using a calculator, then there must be a better way of constructing that question. But anyway, having written that bit, this part 1 was, you had to be so careful marking this because you had to justify that you knew the student had done it without using a calculator. Okay, and that means that all of the steps have to be there. This without using a calculator business here. Well, we know what we're doing. It's the intersect where these two things are equal. So we're solving the equation. E to the 2x is 8, e to the minus x. And so we think about how we deal with that as an equation. There are a number of ways we could deal with it. We're just doing logs with the Core 2 gang this week with the lower sixth. And I think one of the things we might say about this one is that you probably start by writing it like that and then multiplying both sides by e to the x because that split term is a bit of a problem. You can get around it, but it's a bit of an issue. I'll show you how you could have done it. You could have, well, we'll do that in a minute. And then having got here we say if e to the 3x is 8, then that means log, what does that mean? That means 3x is the natural log of 8. That's what we get, isn't it? That's our rearrangement of that rule. So x is a third times the natural log of 8. Now, this is the crucial thing, and I just need to remind myself exactly what we couldn't allow. Yeah. I know that most of you know that a third of ln 8 is ln 2. You're happy with that. You know why it's ln 2. You can stick it in your calculator and check it's ln 2. You even know that you're looking for an answer that is ln 2. That's 1 mark out of 2 on this question. That is not enough because it's said without using a calculator. And as far as I can see there, you haven't demonstrated that you know how to get from there to ln2. So you have to have, especially if it says without using a calculator, but whenever it says show that, whenever it says that, you have to be so careful to justify every single thing that you've done. So you need to have a line in here that says x equals ln 8 to the third, or ln the cube root of 8. Somewhere that you have demonstrated that you know how to get from there to there. And it actually says in the mark scheme, going immediately from x equals a third ln 8 to x equals ln 2 does not earn the second B1. I suspect, for those people marking this last summer, that was quite a common thing that, you know, when papers are checked, when the seeded papers are looked at, it's quite a common thing that was pulled up. Because it's really easy, you know, you look at an answer, you see they've done the right things, they've ended with ln2, you give it 2 marks. But it had to be every step. Just a little side point here, you could have said ln e to the 2x is is the natural log of 8 e to the minus x. You could have then said, I can't fit this in, you could have then said that ln 2x is ln 8 plus ln e to the minus x. That's because I'm trying to squash too much over there. Okay, so that would have been alright, which leads you to saying 2x is ln 8 minus x, because the minus x comes to the front, and you get to 3x equals ln 8 that way, and we're at the same point. So you could have done it that way by starting by taking natural logs of both sides. I think that's a little bit more secure, isn't it, doing it that way? That was only 2 marks. Find the area of the shaded region, giving your answer in simplified form. So we now know that that point there is LN2. In fact, we already knew that that point there was LN2, because the question told us that. So what we're going to do is we're going to find the area underneath the top curve between 0 and LN2, and we're going to take away the area under the bottom curve between 0 and LN2. Our limits must be 0 and LN2, mustn't they? Because they're the values that we're working with. So the area in part 2, the area is the integral from 0 to LN2 of the top curve, which is 8e to the minus x. Take away the bottom curve, which is e to the 2x dx. Bear in mind that without using a calculator clause, covered both of these parts. It wasn't in part 1, it was before part 1. It was before any of the questions were asked. So we can't use a calculator here either. If we integrate e to the minus x, we know that if you integrate e to the ax, you get 1 over a e to the ax. So that becomes 8 over minus 1 e to the minus x. This becomes a half e to the 2x between 0 and ln2. Again, we've got to demonstrate non-calculator usage. Odd thing to say. So that's minus 8 e to the minus ln2 minus a half e to the 2 ln2. Take away minus 8 e to the 0 minus a half e to the 0. I am going to be so careful to make sure I demonstrate absolutely everything is being done without a calculator. This is, well hang on, what have we got here? This is minus 8 e to the ln a half. Do I need to write that? I'm going to write that. I'm going to write that. And this is minus a half e to the ln 4. Take away minus 8 minus a half. Those bits I can deal with because it's just to the 0 makes it a 1, doesn't it? So this is minus 8 times a half. This is a half times 4. And I reckon I'm nearly there with that. I've got minus 4 minus 2 plus 8 plus a half gives me, what is that? 8 take away 6 is 2 plus a half is 2 and a half, 5 over 2, and there's my answer.
Did you say that you weren't going to use a calculator for the second bit as well?
Exactly.
Oh, alright.
That without using a calculator covers both part 1 and part 2.
It's a good thing I didn't there.
Good, well spotted. Did the person who was marking your paper notice that you've got an answer of 5 over 2 but clearly had used a calculator along the way and not give you all the marks?
Right, I got full marks.
You got full marks? Oh, okay. Maybe somebody had better have a little...
No, I didn't do the calculator.
Right, okay. And that's maths.